This is question number one from different general question from different years. It's a question from June 16 and says that choose from the following polymers. So this question is all related to the polymers to answer the questions. Right now, let's have a look at the polymers. What is this linkage known as NHC double bond O? This is basically my amide linkage. Now, amide linkage may I have got two polymers. One is your nylon and another one is your protein. Now, just looking at this particular, what you call it, the structure, can we guess whether it's nylon or protein? Look here, the amide linkage ka mirror image you can see, NHC double bond O, C double bond O NH, NHC double bond O, C double bond O NH. So I can quickly identify that where an amide linkage ka I get the mirror image. Wherever I'm going to get a mirror image, that means I have a nylon here, right? So this compound is nylon. Now I'll be moving on to the question, but just looking at all these polymers, I'm just trying to recap that concept of polymerization. Now, when you talk about the compound, the next one, that's the polymer B, I can see here that there is no specific linkage like ester linkage or amide linkage. So this is an example of your addition polymer. This is an example of addition polymer, right? And the addition polymers are generally known as plastics, and they are difficult to disintegrate or difficult to break down. Now, the polymer C, we have an example here. The polymer C, we have an ester linkage here. Now, of the ester linkage, we have two ester linkage examples polymers. One is known as polyester, and you can also call it terylene. Apart from polyester, we have another one, that's fat. Fat is easy to identify because वहां पर ester linkage one over the other 3 times connected होती है, ठीक है? So that's an ester. Fat is an ester, right? In the terylene, we will be seeing the ester linkage again in the mirror image form, in continuation, in the line form. So this is basically my terylene, right? So this C is basically terylene. Now moving on to the D. Now, when you talk about the D here, the D has an oxygen linkage. An oxygen linkage will be there in carbohydrates, right? So in the carbohydrates, you have oxygen linkage. Coming to the next example, that's basically polymer E. Now, polymer E, this is one unit which is connected to similar unit, So these are basically what? These are basically my repeat units. And I cannot see an ester linkage or I cannot see an amide linkage. So this is again an example of my addition polymer. This is an example of addition polymer, right? And in this repeat unit, how many carbon does it have? 1, 2, 3. So this is basically my polypropene, which is my addition polymer. Now coming to the next example, we have the next polymer, which is given to us as F. Now in this again, there is a repeat unit. These are the repeat unit linked together. This is again, there is neither ester nor amide. This is also an example of addition polymer. And here, what are the simple repeat unit? They have one chlorine here. So this is chloro, how many? It's chloroethene here. Okay, that's a monomer, right? Coming to the next part, the polymer G, we have the amide linkage. And now in this amide linkage, you can see the exact replica. So amide linkage we had in nylon or protein. In nylon, we have seen there was a mirror image. Look here, NHC double bond O, C double bond O, NH, NHC. But here, NHC double bond O is exactly replicating. So in this scenario, we can confirm that this is a protein because amide linkage is present either in nylon or protein. In the nylon, you will be seeing the mirror images, and in the protein, you'll be seeing the exact copied linkage in the same format. Okay. Coming to the last one, we have again ester linkage here. If I'll move up, then this, okay, hold on, let me try. Okay, oh, see, I was telling na if go back to the last part, the polymer H. In the polymer H, we again has got an ester linkage. And when we have an ester linkage in the line form like this, then that is again an example of your polyester. right? This is also polyester or it's sterylene. So my polymer C and my polymer H, they both have an ester linkage. They both are basically different type of polyesters. Okay. Now we have an understanding about these polymers. Let's go back to the question, actual question. I hope this much is clear. Let's go back to the actual question and let's see the demand of the question. Okay. The question says that, okay, now there's one more polymer, that's I. You have a carbon connected to 4-fluorine. So this is basically tetrafluoroethene, right? So you have, which is generally known as Teflon. Now the question says that each polymer can be used once, more than once, or not at all. Which two polymers are polyester? So we have to pick up the polymers which have C double bond O and O, this linkage present. So let's see which of them has got this linkage. Then we'll be writing their names here as the part answer to the part A. For that, I'll be going up and check it out. Come on, help me out with the answer. So answer is going to be polymer C and the answer is going to be polymer H because C and H have got ester linkage. Coming to the part B, which polymer is used to make both cling films and plastic? Now, as I already told you when I was explaining you that the addition polymers are generally known as plastics. So addition polymers are those where you can easily witness and identify the addition polymers where you don't see the ester linkage or where you don't see the amide linkage. So those are basically the example of the addition polymers, and addition polymers are generally, we can call them plastics, right? Because they are non-biodegradable. So let's see, it can be propene, it can be polypropene, it can be, right? So we have to look for an example, which polymer they're expecting us to find out just one, which is used to make cling films. Let's see the options above. So we have here the polymer E. The polymer E is actually a propene, so it is going to make polypropene, which is used for making the cling films. And similarly, you can also, the answer can also be your polymer B. Can you see the answer, polymer B? The polymer B is also your ethene, so that can also be an answer to it. So we can write down B as an answer, or we can write down E as an answer. Okay, moving down again to look at which part. Now give the letter of addition polymer. As I told you, addition polymers are those where the elimination of water is not taking place, जहां पर आपका repeat unit amide linkage या ester linkage नहीं है. तो addition polymers की यहाँ पर जो example हमें नजर आ रहे हैं वो polymer B है, addition polymerization का example, क्योंकि ना उसमें ester linkage है ना amide linkage है. Polymer E है where you can't see ester amide linkage. Then polymer F can also be your addition polymer, and polymer I can also be your addition polymer. So and out of these four options, you can write down any one option. Now give a letter for the condensation polymer. So how will you identify the condensation polymer? So condensation polymers are those where you can see either the amide linkage or you can see the ester linkage. So if you look at the amide and ester, then A has an amide linkage, then C has an ester linkage, A has amide linkage. So these are the example of condensation polymers. G again has got amide linkage, right? And followed by, I think these are the only three examples which are of the condensation. So any one of that, you can write it down. Give a letter for polymer that have a saturated hydrocarbon. So saturated hydrocarbons are the ones where you have a carbon-carbon. What? When you talk about the addition polymers, so you have the example as B, you have an example as E, you have F, and you have I. All these polymers are basically saturated because their monomers were unsaturated when the double bond has changed into a single bond, so they gave rise to these polymer, and these polymers have all your single carbon single bond, right? So they all are saturated. Coming ahead, then we have the next part. Which polymer could be a part of a protein? Now, I told you the protein is the one which has got protein is the one which has got what? Protein is the one which has got amide linkage. Now, amide linkage also, and where you will see the amide linkage in exact form. If it is a mirror image, we say it's nylon. So we will be looking at the amide linkage as C double bond O N and H. C double bond O N and H in this particular form, exact repetition. So in this, is it repeated? No, this is nylon. So let's look for another example with an amide linkage. So NHC double bond O, NHC double bond O, NHC double bond O, NH. So this is an example of your protein. So we'll write down the example. The polymer G is an example of protein. I hope I'm clear with this question. 3. Choose from the following elements to answer the questions below, and there are certain elements which I have given. Now, which element has an ion which in an aqueous solution react with sodium hydroxide to give a red-brown PPT? Red-brown PPT sunte ke saath hi हमें पता है कि it's going to be iron. It's going to be iron, right? Red-brown. Let's see the options. Let's see the options. We have aluminum, we have argon, we have carbon, we have copper, we have iodine, iron. Copper इसलिए नहीं हो सकता क्योंकि copper as a metal is basically is reddish brown. Okay. In beta inert atmosphere means inert atmosphere. देखो air जब आप इंट्रोड्यूस करते हो ब्लास्ट फर्नेस में, तो उसमें 78% जो होती है वो आपकी नाइट्रोजन होती है, ठीक है? और एयर के अंदर यू हैव द नोबल गैसेस एज वेल. नाउ जब आपका मेटल रिएक्ट करता है तो मेटल जो है वो दूसरी चीजों से बहुत जल्दी से रिएक्ट करता है. अगर आप मेटल का चैप्टर पढ़ें तो मैंने आपको अभी बताया था कि मेटल के अंदर हम दो चैप्टर्स पढ़ते हैं. एक हम प्रॉपर्टीज के बारे में बात करते हैं, जैसे फॉर एग्जाम्पल देयर प्रॉपर्टी विद वाटर, ऑक्सीजन, displacement reaction, their oxides reacting with reducing agents, their solubility, stability. दूसरा पार्ट जो है हम पढ़ते हैं एक्सट्रैक्शन के अराउंड. तो अब यहाँ पर ये पूछ रहे हैं इनर्ट एटमॉस्फेयर, तो डेफिनेटली जो मेटल आपने एक्सट्रैक्ट किया है वो इनमें से किसी के साथ भी रिएक्ट कर सकता है. वो ऑक्सीजन के साथ भी रिएक्ट कर सकता है, वो स्टीम के साथ भी रिएक्ट कर सकता है, ठीक है? वो ऑक्साइड बना के उसका फिर फर्दर रिएक्शन. तो these two gases, it can be either nitrogen. Why nitrogen is considered as inert, unreactive? Because it has a noble gas, it has a triple bond. और नोबल गैसेस ये कंप्लीटली फिल कर देते हैं, सराउंड कर देते हैं एनवायरनमेंट को, जिससे मेटल्स जो हैं वो इन कंपोनेंट्स के साथ रिएक्ट नहीं कर सकते, ऑक्सीजन के साथ नहीं. तो एक तरह का होल बना लेते हैं उनके चारों तरफ, उनको रिएक्ट करने से रोकते हैं. तो दे प्रोड्यूसेस व्हाट यू कॉल इट inert atmosphere, for that after the extraction is done, so that they do not convert back into the compounds. आप एक्सट्रैक्शन क्यों कर रहे हैं? आप एक्सट्रैक्शन इसलिए कर रहे हैं ताकि आपको मेटल मिले, ठीक है? लेकिन अगर मेटल की प्रेजेंस, अगर जैसे ब्लास्ट फर्नेस है, ब्लास्ट फर्नेस तो एक क्यूच है, ठीक है? तो आपका नीचे आके यहाँ पर मेटल एक्सट्रैक्ट हुआ, और उस मेटल एक्सट्रैक्शन के साथ यहाँ पर एयर भी है, यहाँ पर ऑक्सीजन भी मौजूद है और डिफरेंट इंप्योरिटीज भी मौजूद है. तो मेटल का एक्सट्रैक्शन का फायदा क्या हुआ? मेटल ने इमीडिएटली जो है ऑक्सीजन के साथ कंबाइन करके ऑक्साइड वापस दे दिया. लेकिन इनकी प्रेजेंस जो है, नाइट्रोजन की प्रेजेंस या नोबल गैस की प्रेजेंस, एक तरह का इनर्ट एनवायरनमेंट क्रिएट करेंगी जो कि फर्दर रिएक्शन ऑफ मेटल विद एनी काइंड ऑफ रिएक्टेंट्स को स्टॉप करेंगी. आई होप आई एम क्लियर. Whose question was that, beta?
Me, Manahil.
Okay, good. Understood. Is it clear?
Yes.
All right. Coming to the next part.